This is a 125 micrometer projection of the Mona Lisa. It wasn't made by a high-end cinema projector, but by a piece of silicon no bigger than a grain of salt. Researchers achieved this by etching an array of MEMS, or micro-electromechanical systems, directly onto a photonic chip. In other words, these are microscopic mechanical structures like little cantilever beans that can be physically moved using electrical signals. By integrating these onto a photonic integrated circuit, the team could use electricity to physically wiggle the silicon waveguides, steering beams of light with nanometer precision to form an image. And by applying a voltage, they could tilt these tiny waveguides to steer light beams with insane precision. In their first test, they successfully projected a 125 micrometer version of the Mona Lisa. It's built on a standard 200mm CMOS compatible platform, and this means it can be mass-produced in existing semiconductor fabs. And because it uses electrostatic forces rather than thermal tuning, it only consumes microwatts of power. It's essentially dark when it's not moving. And it also solves the alignment problem. Traditionally, getting a light from a laser into a tiny chip required active alignment, which is slow and expensive. But this chip uses its own MEMS to self-align the beam. The researchers think this is the missing link for lightweight AR glasses. So instead of heavy prisms or lenses, the entire projection engine could just be a tiny speck of silicon sitting on the frame. This breakthrough proves that we can now move away from bulky hardware and towards active silicon, where the chip doesn't just process data, but instead it actually physically interacts with the world. If you want to stay updated on the latest breakthroughs in tech, be sure to subscribe to the BetterStack channel.